Welcome back. Today we're going to look at section 6.5, exponential and logarithmic equations. So today we're going to be solving, and to do that we either have to convert between one form and the other to help us solve, and then we're going to look at some applications, word problems for these as well. So what I've done for you, and this may help, may not, but I tried to kind of put everything together as the types of problems you'll be working with. So basically, you have two types of exponential problems that you might see. So I've given you some examples over here, and then two types of logs, okay? So when you have an exponential function, you're going to kind of look at which one of these do you have. Do you have an exponential problem where you can get the same base? Or do you have an exponential problem where you cannot get the same base? So if I look at the first one, my answer would be yes, I can get the same base because I can write 16 as 4 squared. So that would be the first type. And if I look at the bases of 3 and 5, there's no way I can get the same base, okay? So I call type 1 problems ones that I can get the same base, and I call type 2 problems where I cannot get the same base. So these are the steps that you would do if you have those kind of problems. Okay, so we're going to go through these. So I'm not going to read the steps to you right now. We'll do them in just a minute. And then the same thing for logs. You have basically two types of logs. First type of log is your equation a problem where every term is a log? So look at this example. Log of x, log of 5, log of 50. All the terms are logs. That's one type of a logarithmic problem. And then the second type is, are some of the terms logs, but some of the terms not logs, so just numbers. Okay, so in this example, I've got the log of x, the log of 4, but I just have the number 9. So that's the difference of the two logs you'll see. So they're very easy to pick out. So this is my type 3, when all the logs are the same. And then my type 4 would be when you have some terms are logs and some are numbers. Okay, so again, if you need to go back and look at the steps after we do this today, then that's what it is. And then always, for any logarithmic equation you do, you must check your answers and make sure that your answer is in the domain. Okay, so we'll talk about that when we get to those. So let's start solving, and these are going to be type 1 problems. The very first two of these that we're doing, type 1. I can get the same base. Okay, I can get the same base. So if you can get the same base, get the same base. So if I'm looking at the numbers 8 and 16, the base would be 2. Okay, 2 to the 4th is 16, and 2 to the 3rd is 8, which means this would be 2 to the negative 3. So I can get both of these to write them with the same base. So that's what I'm going to do. So 16 is 2 to the 4th, and I'm going to keep the exponent that was already there. And then 1/8 is 2 to the negative 3rd. Keep the exponent there. Okay, so that's your first step, is to get the same base. Now you're going to multiply your exponents together. So this is a distributive property. So 4 times x is 4x, and 4 times negative 2 is negative 8. Same thing on this side, we're going to distribute. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. Once you have everything simplified, now you can drop the bases and you set the exponents equal to one another. So 4x minus 8 has to equal negative 3x plus 3. And we're just solving that. So we're going to add 3 to this side, which becomes 7x. I'm going to add the 8 to this side, 11. And I will divide, so my answer would be 11 over 7. Now, when you have exponential equations, you do not have to check the answer because the domain of any exponential function is all real numbers. So that definitely is an answer. You only have to check your answers when you have logs, okay? All right, so look at example 2. I got 3 and 1 over 27. Those are both powers of 3. This is already done. I don't have to do anything to that side. And then remember that 27 is 3 cubed, so 1 over 27 would be 3 to the negative 3rd. Okay, keep that exponent. So this side's done on the left, don't have to do anything over there. I will multiply these, so that's negative 6x plus 3. Multiply the 3 through. drop your bases, set your exponents equal, and solve. So I'm going to add 6x over to this side. That'll make that 7x. Add 1 to this side, make that 4. So I end up with 4 over 7. Okay? So that's type 1, when you can get the same base. All right, so now let's look at the type 2 problems. So first and foremost, when you do exponential problems that are not the same base, you must get down to just 3 parts of the problem: the base, the exponent, and the answer. Until you have that, you can't do the type 2 problems. So when I look at example 3, I can't multiply before I raise 5 to the power. So I can't make this 35. And I can only have one base raised to the power. So I need to get rid of the 7 by dividing it over to this side. So that would give me 5 to the 12x equals 3. Okay, so that's what I mean by you must get yourself down to having one base, one exponent, and the answer. Once you have that, then you're ready to do these problems, which is simply to write this in logarithmic form. Okay, that's all you got to do. So we do the log of the base, which is 5. So log base 5 of the answer, which is 3, equals the exponent. Okay. And now you'll solve for x, so you're going to divide both sides by 12. So there's your answer, okay? And remember, you can leave your answer like that, or we can put it in the calculator and get 5. All right, so we can put it in our calculator. We're going to go to alpha F2, get your log button, or do your change the base formula if you need to. So log base 5 of 3, enter, divided by 12. Remember, this is an approximation, so we're going to round. So we'll approximately say it's 0.0569. Okay. So again, sometimes on the final, they'll give you, this is your choices. They won't give you the decimal. Pay attention on Hawks, how it wants you to write your answer. All right, so we got a little bit of work to do because my base here is e. So I got to get rid of the 6 and the 3. So we're just going to do this regular algebra. So the first thing we're going to do is move the 3 over by subtracting it. So 27 minus 3 is 24. Then we're going to get rid of the 6 by dividing. 24 divided by 6 is 4. Now that we have our 3 parts, base, exponent, answer, we can write this as a log. So log base e is natural log of the answer equals the exponent. Okay? Now, notice I'm always putting the number I'm taking the log of in parentheses, because once you write it this way, you can't change that number. And I have a lot of students, if you don't put that in parentheses, like the next step would be to subtract 1. Well, when you subtract 1, it's not going to become a 3. Okay, the natural log of 4, you have to do that first. That's a decimal number. Then you would subtract 1 from that. So when you do this, if you put it in parentheses, that helps you kind of remember not to change that number. So when you subtract the 1, you put it off to the side. And then the same thing, when you divide by 2, you divide by 2. So nothing changes that natural log of 4. Okay, that's got to stay that way the whole time. So there's your answer, exact answer. And then the approximation, if you wanted to put it in your calculator, the natural log of 4, make sure you close your parentheses, minus 1, divided by 2. So we get 0.1931. Okay? All right, example 5. Got to get down to e to the x. So we're going to add 3 to both sides. 23, divide by 14. Okay, I'm just going to leave that as a fraction. So now I'm ready to write it in exponential form. So the natural log of 23 over 14 equals x. So that one I don't have to do anything. There's my answer. And now I can get the approximation, the natural log 23 divided by 14. So approximately 0.4964. Okay. Again, pay attention to Hawks, how it wants you to round, what place to round to. All right, number 6 is a typo. That x should not be there. So this side should just say equals 3, okay? So this one is ready to go. We have the base, the exponent, and the answer. So write this as a log. That x was just a typo. It should just equal 3. So this would be the log base 5 of 3 equals x minus 1. And again, when you move the 1 over, don't change that 3. So log base 5 of 3 plus 1 equals x. So that's an exact answer. Your estimated answer would be alpha f2. Okay, so log base 5 of 3 plus 1. 1.6826. Okay. All right, so those are your 2 types of exponential functions that you'll be dealing with. All right, so now we're going to move on to our 3rd and 4th types, which are the logarithmic equations. So these you must check, okay? Must check your answers on these. So we need the domain. So remember the domain, you set whichever log has the variable in it, set that greater than 0. So this domain of number 7, your answers have to be greater than 0. When we get to number 8, we would have x plus 1 greater than 0. So all our answers have to be greater than -1. So that's what you're checking on your answers. Do they fit in the domain? All right, so when you're solving logs, this is type 3. Every term is a log. Every term is a log. Same thing here. This is a log, this is a log, this is a log. Okay? So when you have the type 3 problems, your rule is to condense each side down to 1 log. You must do that all the time. Every side can only have at most 1 log on it. So 2 logs being added can be condensed by multiplying. Right? Okay. So log of 7 plus the log of x is the same thing as the log of 7x. Once you have 1 log on each side, and this is important, then you can drop the logs and you set the answers equal to one another. What students will do is say, oh, I can just cross out all these logs and do 7 plus x equals 35. No, okay? 1 log on each side first, then you can do that, then you solve. So 35 divided by 7 is 5. Check it, make sure it's greater than 0, which it is, so that is the answer. All right, over here you have 2 logs being subtracted, so we can condense it by dividing. Right? Okay, now I have 1 log on each side. Now I can get rid of those and I set the answers equal. So I'm going to multiply the x plus 1 to the right. Now I can solve this. So 12 equals 4x plus 4. Subtract the 4 over to this side, we get 4x equals 8. So x is 2, which is greater than the -1, which is the domain. So that is the answer. Okay. All right. Number 9. This one is type 4, the last type. Look at these 2 up here. I've got a number, a log, a number. I've got a log, number, log. Okay, so this is type 4. Some of the pieces are numbers, some are logs. When you have that, all the numbers need to be on one side and all the logs need to be on the other side. And you always want the first log in your problem to be positive. And it's going to make it easier on you when you solve them. So when you start, try to always have at least 1 positive log to start your problem with. All right, so I'm going to leave the natural log of x plus 2 on the left, where it is, and I'm going to bring the natural log of 3 over, so it'll become negative. Then I've got the 6 on the right, which is positive, but I need to bring the 5 over the equal sign, so that'll be a -5. So I moved all my logs on the left, moved my numbers on the right. So I've got 2 logs being subtracted, so I know I can condense those by dividing. and then you just work your numbers. 6 minus 5 is 1. All right, so once you get down to, now notice I don't have a log on both sides, so you can't just cross this out anymore. I don't have one over here to cross out. So these are type 4, and all you do differently with type 4 is once you get down to a log equals a number, then you must write it in exponential form. There's no other way around it. So what is the base? E, and here's your exponent. So e to the first has to equal x plus 2 over 3. And we just solved that. Remember, e is just a number. So e to the first is just e. So we're going to multiply the 3 to this side. So that's 3e equals x plus 2. Subtract 2 from both sides. So there's your answer. And again, you could put that in your calculator if you wanted to get the decimal. So 3e minus 2. So 6.1548. Okay. All right, so I'm gonna probably stop putting them in my calculator. We'll just leave them as the exact answers, but you can keep going and put those in your calculator if you want. All right, so look at this one. This is a positive log, so I'm gonna leave that here. I'm gonna take this -3 and put it on this side, make it positive. And now I've got a negative log on this side, so I'm gonna bring it over here and it will become positive. So moving things around, I'll have log base 2 of x plus 4 plus log base 2 of x plus 6 equals 3. Okay, moving things over, this became positive and so did that. So now I got to condense. You always have to get down to 1 log on each side. So we're going to multiply these together since it says plus. So we have x plus 4 times x plus 6 equals 3. All right, so I think first let's go ahead and FOIL this out. Okay, so we're going to FOIL. So log base 2, so x times x is x squared. Outer is 6x, inner is 4x, so that gives you 10x in the middle, and 4 times 6 is 24 at the end. All right, so again, I can't cancel this log, so I'm going to write it as an exponent. So there's your base, there's your exponent. So 2 to the third has to equal the answer of x squared plus 10x plus 24. 2 to the third is 8. So 8 equals x squared plus 10x plus 24. Since you have a quadratic, this side must be 0. So we're going to subtract 8 from 24. So that gives you x squared plus 10x plus 16. Factor. Okay. So this factors x plus 8, x plus 2. And you end up with -8 and -2. Now, I got to check my answer, so I got to stop for a minute and go back here. I do this sometimes, and you will too. I forgot to check. Okay, so look at your log. X plus 2 had to be greater than 0, so your answer had to be greater than -2, which it is. So I always put check marks because that reminds me that I checked or not. Okay, so now if you look at number 10, I've got 2 terms with x in it. Okay, so if I was finding the domain, I would set x plus 4 greater than 0, and I'd get x is greater than -4. But I also have x plus 6 has to be greater than 0. So x has to be greater than -6. When you have 2 terms that have x in it, you have to take the greater of the 2 numbers, because both of these things will have to be true. All your numbers have to be greater than -4, and they have to be greater than -6. Well, for that to happen, they have to be greater than the bigger number, okay? Because if I give you -5, then it wouldn't work in here. So you take the larger of the 2 numbers when you have more than one variable in your problem. All right, so is -8 greater than -4? No, it's not, so that is not an answer. Is -2 greater than -4? Yes, it is. So this problem, even though I had 2 possibilities, only one of the answers is in the domain, okay? So that's why it's real important for you to make sure that you are checking your logs to the domain. All right, moving on. Let's look at number 11. All right, so notice again, you have two terms with x in it. So if I was looking at the domain, x plus 8 has to be greater than 0. So x has to be greater than negative 8. But this one says x minus 7 also has to be greater than 0. And x has to be greater than 7. So for numbers to be bigger than negative 8 and bigger than 7, they just have to be bigger than 7. So that's what you're looking for number 11. All right, now notice this is a negative log, but when I take this negative log and bring it over, it's going to become positive. So this is what I want first. Okay? You always want the positive log first. So x minus 7 minus log base 4 of x plus 8 equals 2. So all I had to do in this problem was take this log, move it to the left, make it positive, and I wanted it first because it's always easy to solve a problem with log being positive. You always want that first log to be a plus, okay? All right, so now you have two logs being subtracted, so we can condense by dividing. Okay. All right, log base 4, forgot my 4 there. All right, so now that I have this, I'm going to write it as an exponent because I can't just cross the log out. Remember, you can only cross the log out if you have a log on this side. So 4 to the second power equals x minus 7 over x plus 8. 4 to the second power is 16, and I'm going to go ahead and multiply the 8 over to this side. Now I just solved that. So I got 16 times x, which is 16x, and I have 16 times 8, which is 128, equals x minus 7. Subtract the x to this side, that gives you 15x. Subtract 128 from that side, that gives you negative 135. And then we're going to divide 135 by 15, and that gives you negative 9. All right, is negative 9 greater than 7? It is not, so that is not an answer. So this problem has no solution. And I guarantee you, final exam coming up, that's going to be one of the choices if it's multiple choice. So if you don't check, you're going to get the problem wrong. Even though you worked it out right, you're not going to get credit for it because you didn't check your answer. So please be careful with that. All right, let's look at the domain of number 12. X has to be either greater than 0 or x plus 15 has to be greater than 0, which is negative 15. So bigger number, so all your answers have to be bigger than 0. All right, so got the log of x. Let's bring that log of 15, x plus 15 over. So when we move it over, it'll become positive. And that's going to equal 2, okay? 2 is already positive on that side. So you have two logs being added. So we're going to multiply those together to condense. Okay. I'm going to go ahead and multiply this out. So log of x squared plus 15x equals 2. Write this as an exponent. So 10 is your base to the second power equals x squared plus 15x. 10 squared is 100, and I'm going to move it over to this side since I have a quadratic. It needs to have a 0 over there. Minus 100. And I need factors of 100 to give me 15, so I'm going to use 20 and 5. So x plus 20, x minus 5. So my two possible answers would be negative 20 and a positive 5. All right, set those equal to 0. I have to have numbers greater than 0, so negative 20 won't work. 5 is my only answer. Okay. All right. Two more of these, and then we'll look at the word problems. All right, so I've got a log. So again, this is the last type. So I'm going to bring the log base 3 of 4 over to this side. While I do that, I'm also going to fix my exponent. So that 2, remember, is the exponent for x. Bring the other term over. Okay, so 2 was the exponent here. That log needed to come over, so it became negative, and then that 2 stays where it is. So you got 2 logs being subtracted. So that means you're going to divide x squared by 4. Now you're going to write this as an exponent. So 3 squared equals x squared over 4. 3 squared is 9, and you're going to multiply the 4 over here. So 9 times 4 is 36. Take the square root of both sides, so plus or minus 6, right? Square root. But let's look at your domain. You'll just have an x here, so x has to be greater than 0 is your domain. So you can't use negative 6, so your answer would just be positive 6. Again, if this was multiple choice, you would see plus and minus 6 is one of your answers. Okay, so please check your results. Again, it helps put that little check mark. We know we did it. All right, number 14. Got a log equal to a log. So this is type 3. The logs on both sides. So all I got to do is get rid of that 2, make it the exponent. So log base 5 of x minus 1 squared equals log base 5 of 64. Now I'm down to 1 log on each side. So now I get to get rid of those. So that's the difference. If you have a log on each side, you just get rid of them versus writing them as an exponent. All right, so that's a perfect square, so we can get rid of the squared by taking the square root of both sides. So x minus 1 equals plus or minus 8. And then we're going to add 1 to both sides, so plus or minus 8 plus 1. So we get 2 answers. Positive 8 plus 1 is 9. Negative 8 plus 1 is negative 7. Okay, look at your domain. X minus 1 has to be greater than 0. So x has to be greater than 1 is your domain. So this is not going to work. So 9 is your answer. Okay? All right, so I'm going to stop the video here since we're closing in on 30 minutes, and I'll do a part 2 with the word problems coming up next. So you can either continue on with part 2 or you can start your homework and work on these. Okay?